Alright, look, I have a real whiteboard again. And today we're going to be talking about quantifiers. Now, the thing about quantifiers is that their purpose is to intelligently say things about sets of stuff. So, let's say, for example, um, we have a set X and we call that X all the students at MSUB. And there are some things that might be true about every single student at MSUB, and there might be some things that are true only for some students at MSUB. And for each individual student, you want to be able to make some sort of intelligent statement about what that student does or doesn't do. And you can think that this would extend to any set of things where those things are different. If those things are different, then they'll have different properties, and we want to intelligently address that. So let's let X be an element of a set, and then S of X is a statement about X. And the question is it true? And for which X's is it true? So, as a very quick and dirty example, we said that we'll let the collection of X's be MSUB students. So we can just let M of X be the statement X takes a math class uh, in spring 2018. So that would be true for most of you here watching this video. It would not necessarily be true in general though. And that's in comparison, let's make up a different statement, and let's say uh, g of x is x takes a math class before graduation, and that would be in fact be true for all possible x's that we're talking about here. So the two statements, the two quantifiers in question are the for all quantifier and the there is or there exists quantifier. It's an upside down A, line through, and this is a backwards E. And so the for all quantifier, A of S of X, that's the statement S of X is true for every X. So for every single possible value of X, that statement there is true. And the exist quantifier, exist S of X just means S of X is true for at least one X. So if there are any X's that make the exist statement true, then the existential statement here as a whole is true. So we can take a look at our M and G here, so we can ask ourselves, for example, for all X, M of X. So is it true that every student at MSUB is taking a math class in spring 2018? And we'd probably regard this as false. There are probably certainly students who are not taking math this semester. If we want to know, however, whether or not there exists uh, students taking math this semester, then sure, I have some in my class right now. I have you guys right here watching this. So there certainly exist students taking math this semester. Now, Do all students need to take a math class before they graduate? Yes, right? That's certainly true. All students have to at some point take a math class as a general rec and probably for their major. So that is a true statement. Are there students who need to take math classes before they graduate? Yes, there's at least one student who needs to take a math class before they graduate. For example, you, and also, everyone else. So that's also true. As long as there's any students that make that true, then that is a true statement there. Um, and so sometimes, for example, these statements can be implications. So, or and statements or statements. So let's say every student must graduate on time or stay late or drop out. All right, this is true, certainly, right? Every student here, either they're going to make it their 4 years, or they're going to stay longer, or longer than 4 years, or they end up dropping out. Let's by dropping out also include just leaving the university to transfer somewhere else. In some way, shape, or form, they are not uh, making their full time here. So that would be something like for all x, graduate x, or stay late x, I'm gonna call it STX, or dropout x. Right. So there's multiple statements here that could be combined under this quantifier. There are also let's use another student example and say there are students who, if they cram the night before, for exams, they pass. And so something like that would be maybe there exists students X such that cramming implies passing. Right? So X crams, X pass, cramming for X implies passing for X. So how does this relate to what we're doing now? Well, we've been talking about translating things and negations. So let's talk about what negating uh, quantifiers would mean. So let's take a look at some of our statements here. This is false, right? We said that for all math students, that every student is taking a math class in spring 2018, that's a false statement. So how could we make it true? Well, if I were to say that every student is taking a math class this semester, all that needs to happen to make that false is for there to be any student who's not taking math, right? If you say something happens to everyone, then as long as someone's not doing that, then it's not true. So the for all m of x becomes, when I negate it, there exists not m of x, there is one student, at least one student, not taking math. this is a true statement, but let's suppose we wanted to negate that too. So it's true that there are students who need to take a math class to graduate. What would happen if that weren't true? Well, what it would mean for that not to be true is that no one needs to take a math class, right? There are no students who need to take a math class. This says there are students who need to take a math class, and we claim that's not true. So the negation of that would be not g of x. For all math students, g of x does not happen. No one needs to take math to graduate. Of course, that's not true, but it is the negation of the statement. So in general, the rules of negation are for all s of x, its negation is there exists not s of x. So if I claim that something happens for everybody, it's false if it happens for at least, if it doesn't happen for someone. And if I say something's going to happen for someone, that's false if it happens for no one. Or for everyone, s of x doesn't happen. And this applies even to compound statements like this. So every student must graduate on time or stay late or drop out. If we were to negate that, we really are negating the statement. For every student, you either graduate or stay late or drop out. And so the not passes through. And so the way you can think about this is if I move a not through a quantifier, I flip it. So the for all becomes exists, and the exists becomes for all. So the for all becomes exists, and I negate the statement here. And if I pass the negation through this, then De Morgan's law happens, and what I have is not graduate and not staying late and not dropping out. And so what we would say about this statement here is our original claim was that everyone has to either graduate, stay late, or drop out. If that's not true, the consequence is that there exists at least one student who didn't graduate and didn't stay late and didn't drop out. Someone managed to beat the system and somehow do a fourth option that I can't really think of what that would be at the moment. And similarly, we say there are students who can cram right before an exam and they'll pass. If that's not true, then what we're saying is that this isn't true. So there are no students who do that, which means for all students, this thing here doesn't happen, right? And for every student, this thing here doesn't happen. What that has to mean is that, well, first let's rewrite this. If you cram, then you'll pass. We know from the previous lectures that that means that either you don't cram or you're going to pass, right? And we pass the not through this statement, the Morgan law once again kicks in, and we get for all not cancel, we get cram of x and not passing. So that would mean is if for every student, if you just cram the night before, you won't pass. So that is how you pass negations through quantifiers. I don't think that your textbook goes through combining quantifiers, but this is a useful sort of thing to just know and to think about. So, we know, for example, that implications are not commutative, right? P implies Q is not the same as Q implies P. That's the converse fallacy. But let's say E of x, y is a statement x eats y. So this first sentence is there exists an ogre O such that for all goblins G, O eats G. And let's compare that to a second statement. For goblins G, there exists an ogre O such that O eats G. Are these the same thing? Well, hold on a second. Am I? No, we can see fine there. All right, great. So are these the same thing? Well, what this statement here means that there is at least one ogre O. So ogres will be big. So there's one of them. There might be more than one, such that for every single goblin G, so my goblins are little guys here, they all get eaten by these O's. So this ogre eats all the goblins. This ogre also eats all the goblins. I suppose if there's more than one ogre, which is certainly possible, that they would have to split the goblins between them. So like someone would eat the arm and someone else would eat the leg or so on. And so that's what's happening here. It says that there are a group of ogres that eat all the goblins. How is that different from what's going on here? So here we says for every goblin G, there is an ogre O such that O eats G. So that means here the focus is on ogres. That's what we start with. Here the focus is on goblins. So we have a bunch of goblins. Let's draw some more here and make one more here. So for each goblin, I can find an ogre that eats the goblin. So maybe this ogre eats this goblin. And then this happens for every goblin G. So for this goblin, I should be able to find an ogre so that the goblin eats, that ogre eats that goblin. And for the next goblin, I could find an ogre. And maybe it's one of the previous ogres, right? It's certainly no one says that each goblin gets their own ogre, just that for every goblin there is an ogre. But notice what the difference is. And maybe a goblin could still be eaten by multiple ogres. That goblin is eaten by this ogre, and a new ogre. And then let's say this goblin is eaten by that ogre, this goblin is eaten by that ogre. Still, every goblin gets eaten, and they get eaten by an ogre. But this scenario is not the same as that scenario, because if I pick an ogre, he only eats some of the goblins here, right? He didn't eat all the goblins. So this situation satisfies this statement, but it doesn't satisfy that statement. This statement says that for every ogre, they have to eat all the goblins. So every ogre has to eat a piece of every single goblin, and that doesn't have to happen here. Here we just say for every goblin, I can find an ogre that eats you. And of course, these then are not equivalent statements, so you can't just transpose the quantifiers here. Now, what would these things look like if they're negated? If I were to negate this statement, So I pass through, I would say for all ogres, there exists a goblin so that that ogre doesn't eat that goblin. And so again, following the lines here, for every ogre, I pick an ogre, it finds a goblin down here so that they're friends. That ogre is not going to eat that goblin. It might eat every other goblin, or only some of the goblins, or even no goblins, right? But each ogre I can identify a goblin it won't eat. The next ogre here maybe doesn't eat any goblins. So any of these goblins could count as the one it doesn't eat, and so on. So for every ogre, there's a goblin that it's not going to eat. Whereas this negation is there exists goblins such that for all ogres, the ogre doesn't eat the goblin. So all that means is that there exists at least one special goblin that for all the ogres, those ogres don't eat that goblin. So we have all our ogres here. And so there exists a goblin so that when I take all the ogres, they look at that goblin and they say, well, we're not going to eat you. You are safe. The rest of the goblins, they all get eaten. Maybe. Maybe some of them get spared. They might all get eaten by various ogres. But there is a goblin who's totally safe. Right? So this is how we want to think about both what multiple quantifiers would entail and also how to negate our quantifiers. All right. Before I end this video, I'd just like to point out one thing. This concludes the videos for Chapter 6. These videos and these handouts give just sort of a broad outline of the concept and how we should think about this material. I don't get too much into the weeds of specific problems because I can't know beforehand what specific problems you have with the homework or what issues or difficulties you may have. So please, if you run into trouble, if there are things in the homework you don't understand, send me an email, send me something through Pearson, whatever you want to do, and I will get back to you. And if you want me to make a video recording going over the details of a specific problem, I'm certainly more than happy to do that. All right. Thank you.